Hello, everyone. Welcome to Next Big Future. I have my friend Randy Kirk with me. We're talking about SpaceX and Starlink. I have, the launch probably on Monday. So we're recording this Saturday. So in 2 days, we should have the eighth launch of the Starship. And after that, we know that there will be the ninth launch will go to orbit and we'll try to catch not just the booster, but also the Starship upper stage. And the other thing was that Elon was, I think, on Joe Rogan and mentioned that, or maybe just he just posted on X that there's going to be, full reusability, which means that they would catch and be able to relaunch both stages, both booster and Starship, and that they would get to rapid reusability next year of both Starship and booster. So I will go over what that all means, what the new version of satellites will do, all that kind of stuff. So here we have a nice little picture from SpaceX of a firing of a booster for like a hold down test. Because then if you have a launch, you'd have both stages of it. So this next one tomorrow, oh, sorry, 2 days from now, we'll have four dummy version 3 satellites. So those are satellites that are like 10 times bigger than the ones they're currently going up, the version 2 mini. So they'll do the stacking, the Pez dispenser coming out of the neck of the Starship, putting out those four satellites. So in this first try, they tried to put up dummy satellites last time, but unfortunately, um, um, version 7, flight 7 blew up for the Starship. Those things happen.
Mhm.
So Monday, they already got the booster onto the launch pad, probably have it stacked, ready to go. The other thing that we'll have is that this year, so we have the new version 2 booster and Starship. So that's the middle version. So slightly taller and bigger, you can't really tell. A lot of other modifications to the version 2 Starship. Switching from version 1 to version 2 last time for Flight 7 may have contributed to the fact that they had some problems with it, where there was some leaks and other stuff, because they changed like 100 things to get to the version 2, not just making it taller and bigger. Version 3, which should launch by the end of this year, version 3 will be even taller, bigger, more changes, bigger, better, lighter, all that kind of stuff. So we're looking at, the version 2 can get like 100 tons of payload reusable to orbit. The version 3 will have double that because they're
Wow.
done things that are more prototypey, like thicker metal and all that kind of stuff. They weren't not pushing it. They just want to get it to work, right? So version 3 will be like, here we're ready to do real commercial stuff. And then, increase fuel load by 30%, um, more liftoff thrust, going from only 2.5 times the Saturn V rocket to 3 times. You know, all that kind of like really good stuff. And then the extra height could be as much as 30 meters, so an extra 25% more in height, which is, like 50 meters, you're looking at like a 20-story building. It's a sorry, 30 meters would be um that would be like 15 stories. Yeah.
Yeah.
So still, not trivial that we're adding here. I'm showing you the International Space Station. One, because the volume inside a Starship would be more than inside the space station, which took 50 launches. But then you see the solar panel array, the wings of the fold out of the solar panels. The version 3 of the a Starlink satellite, compared to a football field, the space station will be comparable to one of these wings of the thing. So it's just like insanely big, right? If I was to put 10 of them to the side, the area would kind of cover, you wouldn't be able to see the space station because you just see version 3 satellites in front of you. And that's 10. We can launch potentially 100 with a version 3 Starship. We may be limited to 50 or 60 in the version 2 Starship.
So, okay, so I need you to slow down
Sure.
for a minute. So you got 50 to 60 of the larger version of these Starlink satellites
Yeah,
that'll fit in the current Starship.
right.
And right now we're putting up about 39, I want to
No,
say,
so we're putting 39 into a Falcon 9.
into a Falcon 9.
We cannot, if we were trying to put the version 3 satellites into a Falcon 9, um, you'd be hard pressed to put five, and then they'd be kind of like, vertical instead of like
Right,
flat,
right,
right?
right.
So it'd be a huge, it's why I haven't launched with the Falcon 9, because it would not
Just
really,
can't, yeah, just doesn't make sense.
yeah.
So, and then you're saying the Starship is larger than the current space station.
Right. Just the um,
This,
upper stage,
or
the
yeah,
upper
just the
stage,
Starship portion
the
is
Starship portion, not the
larger.
booster portion, just the
Right,
Starship portion, the volume,
right,
1,000 cubic meters,
right.
is more than the volume inside the space station.
Okay. So I've heard talk that once we uh, uh, so I mean, sorry, SpaceX has been commissioned already by the U.S. government, NASA, to decommission the space station
Right.
and have it burn up in the atmosphere.
Right.
So then, is there talk yet? I know I thought I heard Elon or somebody saying that they could basically put up a couple of starships
Right.
side by side and have double, triple the amount of usable space, and that because it's such just a round space, kind of a wide open situation, that it would be much more usable.
Right. Right. Well, the other thing, the space station, parts of it, the first pieces that went up, they're like 30, 40 years old. I
Right,
think they're 40 some years old, right?
right.
So just imagine that you had something, made, like a car made from 40 years ago.
Yeah.
Fine, you kept good care of it,
Huh?
but it is freaking 40 years old,
Yeah, right,
right?
right.
So, so in terms of them using that, like computers, the things, fine, the actual computers built into the thing are
Right.
ancient. I bring up laptops and stuff like that, but I'm using a facility and building that is really, really old and things are breaking down, right?
Mhm.
Because it's sitting there in vacuum, going cycling between huge temperature things.
Right,
They've had leaks and other problems
right.
before because the thing was not, it was designed to only last about this long, right?
Okay,
And so
okay.
they're replacing parts and stuff. It's, they're keeping it going, but barely, right?
So would you imagine that this would be a project that NASA would hire SpaceX to put up one or more of the starships for kind of semi-permanent orbit to conduct future experiments? Or do you think this might be something that SpaceX would do as a private company and then
I
charge
would say
people
both. I would say
both?
both. So
Wow.
the thing about Starship, okay, so we'll go to um, next year. Okay, we have rapid reusability
Right.
on this thing. We're making these things. They're working great, right? They're launching all kinds of satellites. We're going to discuss how much satellite capacity you get out of that. The huge difference is the entire thing, booster and Starship, cost right now $100 million dollars,
Right.
right? Because I got like a total of like six engines in the Starship part, and
Hmm.
I got 33 engines in the bottom part, right?
Hmm.
So total just shy of 40 engines, right? The 40 engines in this thing, stainless steel. The engines I'm estimating make up half the cost,
Mm.
right? So the goal was to get each engine down to $250,000, $300,000.
Right.
So 40 engines times $300,000 would be like $12 million, dollars, right? But right now, things are a bit more expensive. Let's double that, $25 million, dollars, 30 million, $40 million dollars worth of engines, right? A million a piece, right? They're not that expensive, but let's just say that they are, right? And then the metal, it's all stainless steel,
Mhm.
not fiber, carbon fiber,
Right.
whatever other stuff, right?
Right.
It's steel, right? So then all the cost is mainly is steel wrapper around fuel tanks. The
Mhm.
fuel tanks, 4,000 tons in the bottom, 1,000 tons in the top, 5 tons. This is mainly filled with fuel, right? And you're using methane fuel, which is very similar to like liquefied natural gas or whatever it is,
Right.
right? And so then I'm just filling it with fuel, right? The giant fuel tanks with engines and with steel,
Right.
right? So $80 million for the whole thing. Why am I talking about the cost? Upper stage, only 6 engines, right?
Yep.
6 engines, the upper stage, mainly a bunch of fuel, mainly a bunch of steel. So I double the cost of the engines. Again, let's say a million a piece.
Right.
Right? Then we're looking at $6 million for the engines, total $12 million for the upper stage,
Wow.
right? How much did the International Space Station cost?
I can't even imagine.
It cost $200 billion dollars
$200 billion.
because I had to do 50 launches or plus of Space Shuttle. Space
Yeah.
Shuttle was, I had to rebuild the thing practically every time. So it cost me
Yeah.
like $2 billion, dollars, at least $1 billion a pop to
Wow.
send those up there, right? And then the equipment was all super expensive, right?
And that was a lot of money.
That was a lot of money. Yeah, well, this is inflation adjusted up to 2010,
Oh, it
right?
is. Okay. Okay.
But
Yeah.
still, 50 launches, hundreds of billion,
Right.
100, $200
Right.
million dollars to get it
Right.
up there.
Right.
One of these things has the volume
Right.
of the whole
Right.
thing. And I only have to leave the upper stage up there.
Yeah. Yeah.
The upper stage, I just said, in the more expensive version where I haven't got the engine cost down,
Yeah.
right, is 12 million, $14 million, right? Versus 200 billion for the space station, right? So then I can toss these 14 billion, $14 million things, willy-nilly, leave them up there, right? Right? They're cheaper than the fuel tank on the space shuttle, right? The giant orange, people remember the space shuttle, it had an external fuel tank filled with liquid stuff
Yeah.
that was orange, right?
Yeah.
It was big,
Yeah.
kind of actually a bit smaller than the Starship, the giant fuel tank on the space shuttle,
Yeah.
right? They were always thinking, if we drag that fuel tank up there, it'd be a nice big volume. We could then convert it into living
Oh,
space
yeah. Yeah.
and then do that, right? And then
Yeah.
we can leave these giant things up there all over the place. But you have to convert what was just a fuel tank
Right.
into a space station.
Yeah.
Starship is built from the get-go to hold astronauts, right?
Right.
Because they
Yes.
will be able to land on the moon. They got $3 billion project to land,
Right. Right.
lunar Starship on the moon. So that means the top third is living space,
I see.
which is that 1,000 cubic meters. I'm not even using the whole thing.
Right.
It's two-thirds of it is still fuel tank.
Right.
Later, if I wanted to, I can remodel,
Yeah.
upgrade, rip out the fuel tanks, and now I have 3 times the volume,
Right.
right? All I have to do is get some welding torches, burn it out, and I'm like within the same volume. I'm not even like cracking the outer hull. I'm just ripping up the piping and fuel tank, and then melting it down or do whatever I do with the piece. I'm not gonna throw it away, because it just becomes space junk. I want to do that, But that's why if I just leave it unmodified, I'm putting a $14 million, what, 10,000 times cheaper than space station,
Right.
utterly modern thing up there, which is why in terms of space stations, we can come all over. And then I think they can get this thing down to like, $5 million,
Right. Right.
right? The $250,000 per engine thing, right? And then the other, again, the rest of it is stainless steel, which goes to the first principles of Elon Musk. I'm
Right.
I'm looking at the actual cost of the metal
Right.
versus why this other thing costing me a billion, $2 billion.
So then it occurs to me that you could literally, when you got the cost down, already the cost that you're talking about, not even what you think it can get down to, you could literally outfit the the living quarters, if you will, to a very specific set of experiments.
Mhm.
You could send the rocket up with 4, 5, 10, however many scientists that you wanted to go up and do these experiments in a vacuum, in weightless situations. You could send it up for 40 days or 60 days or whatever, and then just bring it down. You
That's
wouldn't
right.
even have to necessarily leave it up there. Now you bring it down, you re-outfit it for the next flight
Right.
to the specific laboratory needs that you have.
Right.
Send it back up again. I mean, that's just crazy.
Right. And because my flight cost, because I got full reusability on it,
Right,
I'm taking all the pieces up and back,
right,
then the actual reusable cost is just the cost of the fuel,
right,
$200,000,
right,
right?
right,
So $200,000, I'm taking up 200 tons, which is 200,000 kilograms, or about 400,000, 440,000 pounds,
hmm
right? If I do that for the cost of like $200,000, $300,000, it's $1 a pound, right? So that was before, like now, like, space shuttles have like $5,000 a pound, right?
right.
So that's the, like the price of, 2 ounces of gold versus bottled water,
Yeah,
right? So, so the entire flip of like everything's so expensive. I gotta, I'm so worried because, like everything I'm taking up is costing me, like an ounce of gold. So I gotta like be super careful, blah,
yep,
blah, blah. But like, you don't think that way going on to a bus. You don't think that way going on to even a passenger plane, right?
right.
This cost, gets down to passenger plane costs, right? So that also goes to what am I taking up there? Well,
Yeah,
before I got to plan things out because again, I'm literally making crap out of gold, right? It's just like, or
yeah, yeah,
like
yeah.
so. Just like, of course, I have to be super careful. Oh, the salary has to be this because my cost factor is like I'm working with gold.
Right,
Right? Now it's like I'm doing normal stuff. My costs are how much does it cost me to flip it in the back of my van?
right, right.
So, or take it onto a really cheap Southwest flight, to wherever,
hmm
right?
hmm
I'm thinking about, I'm shoving it, I'm not even paying the $50 fee to bring my check bag on board the plane, right? Like all my costs are not the thing. I'm not I'm thinking different about
Yeah,
the costs,
yeah. The cost, and and again, to be clear, we're talking about the cost of the individual satellites.
right?
So, scientists, governments, whatever, who need satellites put up, right? The cost of the satellites. It's not just the cost of the transportation, which has already dropped dramatically, but now the cost of designing, building, and I think doesn't SpaceX already custom build satellites for people
The
now?
military defense, yes, that's Star Shield program for this, trying to take the mass production. So they've got 7,000
Right,
of the Starlink, version one
right,
and
right,
version two minis or whatever. They have, they mass produce those things. So then, hey, we're the only one making thousands of these.
right,
So then we can make, the 90% is the same, the
right,
communications,
right,
the
right,
computer, all that stuff,
right.
right? And the solar panels on the satellite. And then we just pop out whatever is your special
Need.
equipment
Yeah,
to hold your military satellite, right?
right.
Right. So
So you can really get all of the costs way down on these satellites. And of course, the rule that we know of economics is if you make it cheaper, they will come.
right.
Is that the
And you'll
rule?
move more stuff. Right. So that goes to, oh, we can't even make, even with the mass production salad, we can't bring that much stuff because it's so cheap and easy to bring stuff up,
Yeah,
which is why I say that you'll be moving cargo around the earth, right?
yeah,
I
yeah.
can take from the North American continent over to Asia or
Right,
over to Europe. I can do same day delivery
right,
of regular stuff. And I'm just putting ship a container of stuff
right.
onto this thing and just moving it because my
Yeah.
costs are now competitive with the cost of a regular airplane. Right,
Not according to Elon, not even competitive with an airplane, competitive with a UPS truck.
right, right. Because a airplane costs $300 million. Remember,
Right.
I said that
Yeah.
the
Right.
Starship costs 14 million and
Right.
then probably get down to five. A, you know, big Boeing plane, a big Airbus plane, those things are in the 150 to $300 million range.
Right.
So then, and then the fuel, you think,
Right.
oh, well, rockets use so much fuel. I'm getting up and then I'm coasting and
Yeah.
then,
Yeah.
near orbit and then I'm landing,
Yeah.
right? So the actual fuel use is not that different. particularly if I'm using cheap methane
Right,
versus JP4 jet fuel,
right.
right? So again, there goes to the economics of the thing and how ridiculously game changing this is, which I've gone through before, but it's difficult for people to get their head around. And
Sure.
then the disruption is not only am I 30 times cheaper on the asset, 50 times cheaper on the
Yeah,
asset, right?
yeah,
Because I only have to use the upper stage versus both stages for
right.
point to point on Earth, right? Is that and like to make a bunch of you have to mass produce also the Mechadilla launch towers to catch them everywhere, right?
Sure.
Um, is that that's why I start moving regular stuff, right? Is because it's the actual operating costs become that thing, and I can't, you know, just making 1 million tons, 10 million tons of phthalates, even I don't think that there's, that in the near term, right?
Yeah,
You
yeah.
can get to 10,000 version threes, 40,000 version threes, right? But each one weighs 2 tons, right? So
Hmm.
40,000, that's 80,000, 100,000 tons, which is, oh, that's so much because we're only launching 5,000 tons now per year, right? But with a fully reusable Starship, each
Right.
time, each one of these things, the stack, can launch like 2 times a week, right? That's 100 launches from just one. If I have a fleet of 10,
Yeah.
they're all reusable, right? Then
Yep.
I can launch 1,000 times. At 200 tons, I'm launching 200,000 tons, right?
Right.
Which is more than all the version 3 satellites at 40,000, right? So, and that, in each one of those things, I'm launching like 20 times the bandwidth. So I go to that here. So you can compare the size thing. And then when I launch a Starship full of version 3 satellites versus a Starship full of Falcon 9, I'm going from 60 terabits per second instead of 3 terabits per second per launch. So the
Mhm.
smaller rockets, smaller satellites, 3 terabits per second, one big rocket, 60 terabits per second, and maybe I go up to 100 terabits per second with the next version of satellite or 200 terabits per second. But just for the first version, we're like 60. So 20 times more per launch, right?
Yeah.
So 100 launches that we did last year, 300 terabits per second total deployed up into orbit, right? 5 Starship launches, I do the same thing,
Hmm.
300 terabits per second, right? But these Starships are going to be fully reusable,
Right.
right? So 2025, we're not at fully rapid reusability. We get like, I'm thinking 10 launches off, right? We do, you know, starting in April, May, May, we start launching real ones, and maybe we get to one per week in the last month, and then we,
Hmm.
surge up to 10. We do like one launch a month from, May, June, July. We get 4 or 5 launches off, and then we do get a surge of like start to get the pace up, right? And also you can have like in more than one, we have 2 launch towers, anyway. So maybe we get that. Bit of a stretch.
Hmm. Hmm.
Maybe we'll get 5, right? So then we're at 1,050 terabits per second versus 300 last year. So we're, a little over triple, but maybe that doesn't happen. Maybe to 900, 800, you know, a little below or a little above triple what we
Sure.
did last year.
Sure.
The year after that, now we got a fleet of like 5 or 10. We're doing one a month or, more. Then we can get up to 7,200 terabits per second. There's some questions around permitting, whether we get, 40 launches out of Florida, 40 launches out of California. California being difficult, so it's less about the technology. Technology could easily get us to, 300 launches, but
Got it.
um, it's the and I'd
Right.
also like to make another launch tower
Yeah.
or two in California. Where you make it the launch tower. Instead of Texas, you have to have the launch towers to do the catching and all that kind of stuff, right? So, but with some level of effort, you can get to 7,200 terabits per second, which would be um, what 24 times as much as what we launched last year, right? So
So,
basically, all the satellites you want, all the capacities up there. Yeah.
so do you believe there's a point at which Elon will take off the what do you want to call it? What do we call it here? That well, where he'll change the magic trick and say, no, really, I want all the business, as opposed,
Um, no, no.
no.
One, this would be so much of all the business anyway. He'll be at like he's already at 90% of all payload to orbit. Just from
Oh,
the Falcon 9.
I'm talking about the communications business.
Right.
Yeah,
Um, so no, he will take 30% because
30%. Okay,
30% because he needs to give um, Japanese NTT Docomo. He needs to give the European cell phone to other companies their money and revenue. They'll save them money and they'll work with just like they partner with T-Mobile and the other companies because one, they have spectrum, and then two, they have national interests. To say, okay, he's not going to say, I'm going to put, Japanese phone company out of business. I'm going to put your 10 phone companies, I can put them all out of business, right? The country will say, hey, no, you can't do that, right? We're going to regulate against you, right? If you work with them, take your 30%, give them their piece, make them money, save them so they don't have to make a bunch of extra cell towers.
right,
Of the 5 million cell towers, 2 million might be rural. I don't need those cell towers anymore. That's another $10 billion a year expense. I save you that money, give me 30%. So it's all a positive thing. It's a win-win. I make
right.
money, you make money. I'm not going to try and kill you. I could, but I don't want to because we want to be happy, everyone making money around the world.
Okay, so the answer is all the communications will eventually be done through Tesla satellites. It's just that they'll be sharing the revenue.
They'll be sharing the revenue, right? The
Okay, all
revenue and
right.
profit. Right? And,
Because I noticed they just dropped the residential use to
yeah,
$90 a month from 110 or 120 or
right.
whatever it was. So it looked as if instead of just rural areas,
Yeah.
it looked like maybe they're starting to make a play for everybody.
Right, right. And then the other thing would be that the satellite, because of how you're deploying it, when you have like a metro New York, a
Yep.
Tokyo, you have
Yep.
all those people there,
Right.
right? Because my 7,000, 100,000 satellites are all spread evenly around the world because they're in
Right.
orbits,
Hmm.
right? Then over top of the United States, not even over New York, over top of the United States, I only have 3% of my satellites,
Right.
right? Because the rest around the world. I'm
Yeah.
flying in orbit. I can't
Right.
like,
Right.
concentrate. I can't hover over it because if I was hovering, I'd be 50 times further away, and so that doesn't work. I need to be close.
Right.
So the around over New York, maybe I can only get 5% of the ones that are over North America.
Right.
So if I had 60,000 satellites, which could happen in 2026, 2027, and they're all the version threes, over the United States, I have like 200, right? Instead of 60,000,
Hmm. Hmm.
sorry, I have 2,000. I have 2,000. So
2000.
the one third, 2,000 over the United States. And then over New York or LA, one of the big cities, I would be able to point, say, 100, 200, which would be substantial, right?
Okay.
But
Yep.
it's still a lot less,
Nice.
right? And then that 100 have to serve like the 2000 are serving 300 million people in the United States.
Right.
The one over New York is trying to serve, the 100 over New York are trying to serve like, um, 10,
7 billion.
7 million or whatever, 8 million people, right? And they have higher usage and blah, blah, blah. So as they get so many and as they get more capable, I
Yeah.
can then do better serving the cities, right? But I'd be disadvantaged against fiber,
Uh-huh.
right? But eventually I could. And then the other thing is that closer I get, the bigger the thing I can get. I can get better direct to cell phone communication,
Hmm.
which I think ultimately would be 1/10 to 1/50th of the total bandwidth for the high-speed communication. I could, right now it's far, far less, right? But as I get closer and as I make a bigger satellite, I can, the bigger antenna, the bigger array lets me talk directly to your small cell phone. And then we'll modify the cell phones so that they have a little bit of like not ordinary thing, able to receive the signals better,
Better.
right? So as that happens, it'll take, you know, um, 5, 10 years to get to that really good, I would say that we can get to like Gen 1 communications around the world
Mhm, mhm,
pretty quickly, and then
mhm.
have the texting and voice. It would be very useful. No dead zones if you can see
Right,
the sky. And
right.
then with really good version 3, version 4 satellites, and then getting them closer to the Earth, we can probably get to Gen 2 everywhere, Gen 3, right? But it will still be inferior to some. So there's some real world physics around what we have to do, and then still give something for fiber. Fiber would be, I need 10 gigabits per second, 100 gigabits per second
Right, right.
right here. You can still do that with a satellite, but it'd be like an AI data center off in the woods. That's where I'm giving this all to that one thing that needs
Uh-huh,
10
uh-huh.
gigabits. So which it
Okay,
already can do. They can already do that. They can already get 10 gigabits per second out to a shipping container thing that would have this kind of communications. So it's not like, I'm making up some theoretical thing. It's like
right.
they sell that product. It costs like $1 million a month, but the reason why they're doing it and why it's of value. And also for like, cruise ships and stuff like that.
Yes,
Yeah. So it's the nature of, you can get a lot more communications if you're the only one there.
right.
You're the aircraft carrier flying around, you're the cruise ship flying around, you're
Yeah,
the plane flying
yeah.
over, you're over the ocean, you're by yourself, then all those satellites, you can suck up that communication. But if you're around 7 million other people,
Right. Yes. Yes. I get
yeah,
it. All right. So, and then the Starships that's going up on Monday, I'm sure that there's many, many things it's trying to accomplish, but the ones that seem to be the more obvious, see if I'm right on this, would be retesting the heat shields to see how the new ones are doing.
yeah,
Um, uh, Releasing the dummy satellites, which they weren't able to do last time.
yeah,
Um, Doing the hover landing over
over the
the
ocean.
before it splashes down. And are they going to do the fuel tank transfer test?
Yeah, yeah, they'll do that.
All right. Are there any other things of note that they're going to be doing on this one?
Um, there is other stuff, but nothing I care about.
Okay. Well, that's my point. Yeah. If
Yeah,
you don't care, believe me.
yeah,
Yeah.
yeah. It's important stuff.
Yeah. Yeah.
Needs to be done.
Yeah.
All that kind of thing. They need to get the reliability of the version 2.
Right.
So that's
Right.
the big one. Reliability of version 2. Get the dummy satellites up. Get the hover so that they can be ready to do the actual,
Right.
you know, and then the actual Starship catch and booster catches. They still have the abort. They're still
Yes.
ready to say monitor and say things aren't looking good, not looking perfect. We're going to dump into the ocean because we don't want to risk it. We don't want to.
Okay. So can they do that? Let's say the thing is coming down and it's like 20 feet away from the Megazilla, and all of a sudden they realize there's a problem. Can they put the jets back on like a plane does? And no, it's just it's at a certain point it's going
Yeah,
to
once you're like, I don't know, 30 seconds away,
okay.
you're committed.
It's it.
But that's why they make sure what they're verifying is nothing looks in any way remotely like it's not going to work,
Right, right, right.
right? It can still end up failing. You can still screw up and
Yeah,
okay, well,
yeah,
we
of
thought
course.
we had gave a playing
Right,
margin.
right,
We made a mistake. It still hits and whatever happens, right? But they have, given themselves wide margin to say it must be really looking perfect
right, right, right.
because we're committed, in the next,
Yeah.
10 seconds.
Okay, so we'll remember that. No touch and go.
Right. Once they say, just like we're past blah 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 point,
Yeah,
right?
yeah, yep,
Then it's
yep,
like, okay, we're committed to go
yep,
for the landing,
yep.
right? Then it's got to go. It's not like that commitment point that before then, that was when you could have said,
Right,
okay,
right.
call it off, right? So you have to be sure, they're very sure about, you know, 50 things have to be green.
Yeah,
If you watch the Apollo 13 movie, right, where you have the checkpoints before they launch,
right,
right? Capcom,
right,
go,
right,
blah,
right,
blah,
right,
blah, flight,
right,
go, all,
right, right,
10 things, all go, 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 and then we'll go to launch,
right.
right? Just like that is, the 10, 20 things, everyone's saying, okay, go, 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 go. Yes, everything's good. Engine's good. You know, computer good. Communication's good. All those things are all good. And then you go for the landing, right? Any one of 20 things, 40 things, whatever, any one of them off, any one of them remotely looking like it's going to fail,
Right, right.
then we're boarding. Right. So that's the way the rockets and space works. It's like if anything screws up, the thing blows up.
Right,
So,
exactly. Yes.
so it's like I must make sure
Rapid,
rapid disassembly, rapid unplanned disassembly. RUD. Yes. Yeah. So, and that's why getting this to be so reliable, so cheap is so amazing,
yeah,
right?
yeah.
Yeah.
But
And
but according to AOC,
yeah,
he's not a scientist and he's not an engineer.
yes, which shows that she's a moron.
Oh, is that what that shows?
That's what
Oh.
shows. It shows that she's a moron. Yes. Yeah. So it doesn't say anything about Elon. It just shows you're not smart enough to appreciate, or not honest enough
Honest enough, yes, no
to
kidding.
appreciate. Yeah.
Yeah,
So it shows that you're dishonest and that kind of thing. Because it is amazing. It's like, oh, he only, you know, became rich and figured out how to make money from making cars and rockets. He revamped, so and then, oh yes, he's hired smart people. But again, other billionaires are hiring smart people.
yeah, exactly.
You know, Amazon, Jeff Bezos, he's no slouch.
Yeah,
He got $200 billion. He
yeah,
got Amazon. He figured out cloud computing.
yeah,
But Blue Origin only had one good launch. Congratulations to them, right?
yeah,
But it took
yeah.
them a lot longer, a lot harder to get
I
there.
mean, he's only had three good ideas.
Yeah,
I
yeah,
mean, it's not like Elon, he's got seven companies, but
yeah,
Jeff Bezos only had three good ideas.
yeah,
Pretty good ideas,
yeah.
but
And again, it's like, all respect to Jeff Bezos. It's like he was the one out of like 10,000 guys who were able to make the e-commerce internet company.
and
Yeah,
by the way,
yeah,
I've said it before on my show.
yeah,
I had that idea, almost exactly the same idea. Spent $100,000 on it in
right,
1998,
yeah,
and we gave up. We gave up. It was just that we had an egg and what do you call it? The chicken and egg problem.
yeah,
We needed customers and we also needed suppliers, and we needed both of them at the same time, and neither one of them wanted to be the first to go. And we gave up after spending 100 grand. And again, in that era, $100,000 was a lot of money.
right. I worked on at a company that tried to do something like PayPal,
Yeah.
and that
Okay.
failed. It's like it's
Yeah.
not like other people weren't trying to do those
Right. Right. Yeah.
because it's like yeah, everyone knows. Hey, we do that. It's a crap ton of money. It's the
Right.
execution that's the hard thing.
That's right.
Yeah,
That's right. Yeah.
yeah. So it's but anyway, so for the space stuff, this year we're heading to the transformation. Version 2 to version 3, Starship landing, gain reusability, and they'll be able to launch the satellites even without landing the Starship successfully.
Sure.
Because right now, where we can land the booster,
Yeah.
and then even when we lose, as long as the Starship gets to orbit,
Right.
releases all its satellites,
Right. Right.
right? Then if it fails on landing, it has to dump into the ocean.
Yeah.
That's fine. Because that's basically where we are with Falcon 9,
Right.
right? Where
Right.
like it recovered the booster,
Mhm.
and then we always lose the upper stages,
Right.
right? Because they're not coming back yet.
Right.
Yeah,
Yeah. So I would say that what the to me what the big deal is this year is not just reusability, it's commercial success.
right, right.
Yeah.
Oh yeah, they're already at 5 million customers for Starlink.
Yes.
They have passed that. So they're adding on the order of 200, 300,000 per month, right? And so then, just without increasing the rate, you're looking at, 7 to 8 million. If you increase the rate toward the end of the year, you can, push up to like 10 million customers. And then by the end of 2026, if you're at a 500,000 to a million run rate, you could get to 20 million, 30 million customers, which involves their Texas bathrock factory that's mass producing the dishes, the mini dishes, the cell phone dishes and that kind of stuff. So those products, which will get out to, like every Costco, every electronic store, they need to like get those out there in order to sell
Mhm.
so many of them. Because you need to like be selling as many as Apple sells their their laptops or something, right? You need to get that commercially out there to do that, to get all these products. Yeah.
Yeah, no doubt about it. And of course, we may have to wait until Elon steps down from Doge before they can do it. But hopefully, the Tennessee Valley Authority switches horses and starts using satellites instead of dial-up. I mean, instead of cable. Um,
Are
and
you talking about for
the
the
40 billion dollar contract that hasn't delivered a single hookup yet.
so you're talking about the rural stuff,
Oh no, yeah, rural, not Tennessee Valley.
rural, and then there's also the FAA thing, the
Yeah.
contract with Verizon
Well,
for the fact that they have a failing
but the thing with the FAA, he says he's going to give it to him free.
initially. Yes, yeah,
Yeah, yeah,
yeah. But then he'll give like maybe 4,000 free. They test it, use it, but
right,
that means they don't pay for the initial thing, but then they'll
right.
pay for operations and maintenance. It
Later,
will transition into a commercial.
right.
But
I guess he could do that for the rural broadband also. He could say, look, I'll send out all these dishes for free, but 4 years from now I want to be paid. Or I
right,
don't.
because each one of the dish receivers costs about you know probably
$100.
costs them about $200. They may sell it for 400, 500,
Right.
right? But the actual hard cost is 200. So 4,000 of them would be $800,000, right? So
Yeah.
less than $1 million, right? But then it's the fact that I'm using some of the
Other
capacity, but the
things.
capacity is sitting up there. So the
Yeah.
fact that I'm giving a bit more, the marginal cost is minor, right?
Yeah.
So again, it goes to the fact that you have so much volume and things are so low cost. They say, "Hey, I'll start off doing it this
Yeah.
way."
I just give them to him. Yeah.
Yeah. I'm not going to give you customer service yet. You have to pay for customer service because
Yeah.
that actually has cost,
Yeah.
right?
Yeah.
But me building a bunch of, you
Yeah.
know, um,
Dishes. Yeah. Yeah.
dishes
Yeah.
is trivial. And
Give
then,
him the minis. Give him the minis.
right.
You're free mini. If you're in this area,
Yeah.
give you a free mini, and then I'll give you a year's free because I want to be on the Doge Commission. But
Right.
once I'm off the Doge Commission, I'm going to make a deal
Right.
with the government.
So the cost wise of these dishes is comparable to your LED screen
Yeah,
of your computer. Like if I have a desktop system and I
yeah,
have an LED screen, I have a small TV LED
yeah,
screen. We go to the store and it's like 200, $300 for a 40-inch thing or
yeah,
something like that. The cost and the manufacturing are actually kind of similar,
yeah,
right? So that's, and then you say, well, now we want to make a big one, right? So then we have 80-inch, 70-inch TVs,
sure,
65-inch TVs.
sure.
Those have gone under $1,000. Like
Yeah,
$500 for a
yeah,
70-inch thing.
got one right there.
Right. Right.
Yeah,
So similar thing, I can make a big receiving dish that has that kind of thing. So, and when people think about the cost of how much is a dish going to cost, you can think a rough approximation is
yeah,
how much does a flat screen monitor cost,
yeah, yeah, yeah,
right? And so then and then think about if I want to make a bunch of small ones, right? Again, electronics and other things similar to that. Maybe sometimes you have to double, triple up because something funky about the electronics,
right.
makes it more expensive. But the rough dish itself is using similar manufacturing processes, similar cost profiles of a LED monitor,
Yeah.
right?
Okay.
And then we can produce those by the tens of millions.
Yeah, 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 yeah. Oh, yeah. I'm sure that once he's got his factory down in Texas cranking out exactly the way he wants, he could cookie cutter it in China and or Europe or wherever he thinks it would be smart to have another location.
Right, right. And then the production of it is actually the biggest electronics factory in the United States.
Yeah, you said that, I think.
So,
Yeah.
they have bigger
Amazing.
ones over in China, Foxconn, whatever, making the Apple stuff.
Yeah.
But in the United States, it's the biggest one. And
Yeah.
I think, the way Elon goes, it will become the biggest in the world.
Right.
You
Right.
will have your giga electronics factory pumping out 10 million, 100 million of the dishes, right?
Yeah. Yeah. And to say the opposite of what I just said a minute ago, because of the scale, because you're probably using very few humans, and because of the size of those mini dishes, it might not matter that you ever set up international manufacturing. It might be better just to ship them around the world from there.
Right. Yeah, because it could be things like tariffs,
Yeah, yeah.
who knows how that's playing out.
That too, yeah.
Yeah, if you ever watch this, later in like not March 1st, you know, watch it 6 months from now, a year from now, 2 years from now. Oh, and then the tariffs did this, and then 6 months,
Yeah,
and then the tariffs did that, and then
right,
like,
right. Yes.
right, yeah. So okay, but huge change this year. Huge change this year.
Huge, massive.
Starship 3, and then next year fully reusable, and they will be making many multiples, even this year, getting up to the amount of the NASA budget, going from like 8, 10 billion up to 25, 30 billion, as much as the NASA budget. Next year, multiples of NASA's budget. Just like you can say, okay, like Walmart makes $300 billion, $500 billion of revenue a
Yeah.
year. Apple makes some huge revenue. The revenue numbers will get, and the profit will be nutty. It'll be like 80% margin, like NVIDIA level margins on huge product, but it will still be 10 times, 100 times cheaper than any competing stuff.
Yes, yes,
Yeah,
not even close. So yeah, and I will admit that as much as I want to see them, I want to see them catch the upper stage. I think that's going to be extremely exciting. I want to see them go to the moon. I want to see them start building something on the moon, which will kind of be a prototype of building something on Mars. I want to see them go to Mars with 5 ships, and hopefully they don't all just make craters.
yeah,
So I'm excited about all those things. What I'm really excited about, I really want to see the first inter city to city flight.
yeah.
Where maybe it's Hong Kong for you.
No,
I'm sure that'd be exciting for you. So let's put a little landing port outside of Hong Kong.
yeah,
And maybe that'll be worth flying back to Hong Kong again, because I want to go up and sit at the top of the hill in
yeah,
Hong Kong over the entire, one of the most beautiful sites. If you've never been there,
yeah,
it is one of the most beautiful places you can possibly imagine on the face of this earth, is
yeah,
to sit right at the top of the vernacular
yeah,
and overlook the bay.
yeah.
It is stunning,
Right.
to say the least. In fact, I claimed at one part, I was up there with my business partner, and we claimed that it was the most romantic night we'd ever experienced.
Yeah. Okay. But for me, the dream, yes, I want to do that one trip, but the trifecta trip would be, because it only takes you half an hour to go, across continents and that kind of stuff,
Right,
right?
right, right.
And it'd be going like loading up a roller coaster ride, where it's like you're loading up, loading up, loading up, and then you hop over. No one's feeding you because it's like, like a roller coaster, up and then down. No,
Yeah,
you're not getting, your meal on the roller coaster, right?
right,
So,
right.
so you're going up and down. So then you're doing your flight from, like, say, California to Hong Kong, Hong Kong to Paris,
Paris,
Paris to New York,
New
right?
York,
And
yeah.
then you have 3 meals: breakfast in Hong
Lunch,
Kong, lunch in Paris, dinner in New York,
New York.
right? And then boom, 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 in location. So that would be good, if as close to teleportation
Yes,
as
you
we can
could
get, right? If it was like half an hour, following the physics. Yeah. So that's the kind of like, that would be the knockout day. I'm thinking 2033,
Yeah,
2035.
yeah, yeah.
It can happen.
Could happen.
Right. Okay. Okay. Talk later.
I know.
Bye bye.